All right, as promised, I just wanted to go through our introduction to week one, that is the programming language of C and the integrated development environment, Codespaces in CS50, and talk a little bit about kind of this transition, what we're doing, and how we'll kind of move through the various elements. So we had a very brief introduction to Scratch. I know many of you have used it in the past, and maybe not everyone. The reason for introducing and kind of rediscovering Scratch is simply to see in plain picture language some of the common elements that we'll see continue throughout the course in a number of different programming languages. So big ideas are sequence, selection, and repetition, where sequence just means the kind of sequential order of things that happen in a program or even code. Selection is how do we make choices throughout, whether that's a conditional argument like an if statement, or other kind of pathways that we choose based on inputs of the program. And then repetition is just the loops. How do we do something over and over again? Because, where computer science really shows how algorithms can be most efficient is in the speed and the decision-making process. So computers we know work fast, but we choose to use computers because they can work quickly and they can do the same thing over and over and over and over again and not complain. And they can certainly be more efficient in some of the decision-making process. They don't know all the possibilities that happen, certainly, but that might be a helpful thing to kind of explore as we go down the path. So why then do we jump so quickly into C? Well, I want you to think about, are you the kind of student who loves puzzles, who loves doing math, who loves doing maybe drills or problem sets or things like that? And do you do it in Hungarian? Now, maybe some of you do know Hungarian, but I think about that kind of time when I was growing up and my best friend Mickey spoke Hungarian at home. It wasn't a very common language, and I never really understood a word of what he said. He would talk out loud while he was doing his homework, and so if we were sitting working at each other's house or whatever, he would speak through the problems in Hungarian, and I had no idea of what was happening or what he was doing. So how does this relate? Well, when we convert to the language of C, right, or a new programming language, we often kind of go back to the context of what we already know. And in this case, that would be Scratch. So we use Scratch to show familiar concepts that we've already played with, that we've already worked with, etc., and how might they relate to the world of C. So for example, in class, we talked about this sentence, int main void, or this statement, or this line of code, int main void. And what we said is, yes, there's more there, and we're going to kind of look under the hood, but really and truly, the main method is the point in the code that says, here's where you get started. In Scratch, it's when the green flag is clicked, start here, right? And though the printf is a function, it's an action that allows us to print something to the screen like hello world, we just use the say block in Scratch. So if we can find those kind of analogies, those kind of related concepts, then we might kind of more easily ease into the world of C. And we know and talked a little bit about that there's some functionality in C that we could run much more efficiently and understand a little bit more of what's going on, and maybe a little bit less abstracted than something like Scratch. Because in Scratch, we don't really need to know how to program, we just need to be able to read the blocks and understand kind of the intent of those. So we're just trying to find the parallel meanings in this. Okay, so what is CS50.dev? What is Codespaces? What is going on in here? We've seen this screen, and we talked about it in class the other day, and trying to understand kind of what's happening, right? And it's not that you cannot understand the concepts or grasp those concepts or learn everything that goes on. It's really a functionality of time. How much time do we have in this course? And what do we want to be spending it on? Do we want to spend it on understanding how every little electron moves through the computer and that structure? Do we want to understand how the concepts of programming can be tied to other big ideas in other programming languages? So what Codespaces is, it's really a programming environment built on something called Visual Studio Code. And it's pretty powerful and it's pretty robust and there's lots of tools. But we essentially kind of run that through Chrome, right? Or some browser. It'll run in other browsers as well. And we hide the fact that, in fact, what's going on is that this web page is actually showing us a little bit of what's going on behind the scenes, but there's a lot more, right? In fact, this web page is showing us that there's actually a virtual machine that's running in a Linux environment that's running on a server that's hosting a web page. So again, all these layers to say, well, what's the point of all this abstraction? Well, what we need to do is just spend a minute to kind of explore this, get familiar, and then talk about some of the assignments. So I have my Codespaces here running in Chrome, right? And I've got this weird number letter, and that's just a virtual machine, right? As if you were sitting on a computer that was configured perfectly to run this C. That would be fine, but the minute you go home, now you'd have to configure that same computer at home to do the exact same thing at school. And yes, it does require a little bit of setup. So in order to get through that, we use what's called a virtual machine. So we can remotely connect into this machine and just see everything through a website. All right, and this machine is running a piece of software called Visual Studio Code. And we see that here, and we see it's running through something called Codespaces, hosted at some point through GitHub. Okay. So let's explore this in a little window, and then let's go to a problem set. So down the left, we have all of our tools. We haven't explored all of them yet. We see the document tools, and we have a search tool, and we have source control in GitHub. We'll talk more about that. We have the run and debug tool, and we know we can use some of that here in the command line, but we'll again do more of that. And then extensions, and then additional views might show us, for example, the duck debugger. And that's our little rubber duck that will show up. And I can certainly show or hide more of these tools if need be. So here is my file explorer. It's the Finder in a Mac. It's the yellow folder in a PC, whatever. Now we've got this kind of machine that's going to show us a bunch of folders. And inside a My Documents folder, we've created a folder called APCS 2526. And inside that folder, we're going to create some files, right? And if you notice, this hello C corresponds to this file called hello C. And if I come down here and make hello, it gives me an error. It says there's no rule to make the target hello. And in fact, it's a little misleading. And what it really means is I don't know where make hello is, right? I don't know what's going on. So let's type ls or list command, and I see, aha, APCS 2526 and ZA old. And again, this is my archive of information that we're going to just pretend it's not there. And I have this APCS 2526. So this tells me I'm actually focused here and not inside this folder, right? So I'm kind of standing looking at these two folders like so, and I'm not seeing what's inside. So how do I get inside to this folder? Well, I would change the directory CD and into the directory I want. In this case, it's AP. Now, if I was a little bit lazy, or if I didn't want to type a lot, and if I typed the first few letters, and the letters are unique to the name of the folder, and if I reach over on my keyboard and hit tab, then it'll autocomplete for that. Now watch what happens. When I hit enter, my $ or prompt moves over to the right more, and to the left, now we have the pathway showing me that actually my prompt is inside the APCS folder. So now when I type ls, I see we've got hello with a star or asterisk, that must mean something, and hello.c. And so that hello C file is up here to make it show or work. Great. Now if I type make hello, nothing happens. And that's actually a good thing, because if we don't see any errors printed out, that means the program ran. I'm going to clear it, CLEAR. So now I've just gotten rid of some of the mess and kind of a clear workspace or desktop. I can run make hello, and if I wanted to, I can hit the up arrow to recall the last command or 2 or 3. I think it goes up to 10. So I could run make hello and notice nothing happens. And actually that's a good thing. When you make hello, you're compiling it to a new file, hello.out. Now we don't see the format of that, and it tells us, do you really want to see it? We can open it up anyways, and we can see it and notice, man, it's a really big file, but most of this doesn't make sense. And there's references to like pathways of folders and things like that. I don't need to know that. In fact, when I delete that file and I type ls, notice the file is gone. But I cannot run ./hello like we did in class, because it doesn't have the hello file that we're looking for. So again, there's a little bit of confusion. It would have made sense if we could type this, make hello.c. That is to convert the file in source code that we wrote up here into a .out file, which again is just the compiled or machine code version. And that would make sense, because then I would take this file and make it into hello. But for now, we're just going to accept that make hello, we just reference the file in source code, but we don't need to type the .c. So when I type it, notice what happens up here in the left. Hello shows up, and that's that weird looking file that says, are you sure you want to open this? Now that's the file that I actually run or execute when I type ./hello. And that prints out hello world. So if I change it to a capital H and presumably save it, I can do Command S. And if I run it again, ./hello, it doesn't show me that capital letter has changed. And that's because every time you make a change in your source code, you need to remake or recompile. So change it, make it, and then / it. Let's clear it. I'm going to make a change. I'm going to say hello there. Okay. I'll save it. Command S. Now it does auto-save. I'm just trying to talk through this example here. There may be times when your network's really slow. You might see it kind of delay or show a little dot here, meaning it's not automatically saved. So I'll save it. Then I'll make it, and then I'll / it. Change it, make it, / it. Hello there. Do you see that? Great. Okay, that's it. You should practice this 10 or more times until you're really comfortable with it. Clear it. Make a change. Let's just say hi there. Make it. And / it. Practice this a few more times, and I'm going to come back with another short video about a couple of the problems in the piece that you'll work on. All right, take care.